Welcome back, Calculus. We're going to work on 7.3 now. And this is one of the sections where in a free response, if you come across something like this, usually problems like this are about 5 or 6 points. So it's a pretty big deal. And it's all about separation of variables, which is why we call it variable separation. So anyway, we're looking at this differentiable equation. And the first thing that we do is we just want to rewrite this with a variable dy by itself. And just think of this as multiplying dx over here. So then we have 6x squared plus 6x plus 2. And don't worry about this initial condition just yet. We will worry about that in a little bit. So this will actually get you a point. Of those 5 points, they want to see this separation of variables, so separating y and x. And just think of it as multiplication. It makes perfect sense. So then we can integrate both sides, which is why the integral symbol, we always have a dy at the end. Well, think of it this way, is this is the integral of 1 with respect to y, and that will give you y, just, the derivative of y is 1 in this context. And then on the right side, just remember we add 1 to the exponent and we divide by that new exponent. 6 divided by 3 would give me 2. Add 1 to your exponent and divide by that new exponent. 6 divided by 2 is 3. Plus 2x, and don't forget about plus c. And you can double check that this is right, because the derivative of 2x cubed is 6x squared. The derivative of 3x squared is 6x. The derivative of 2x is 2. And the derivative of a constant is 0. And that's why we had this initial condition at the beginning. Because what that says is when x is negative 1, I don't know what c is yet, we get a y value of 2. And so this solidifies an initial condition that means that we can only have one function, because this is a function, that hits this point. So as I do that, it just, you should be able to do this without a calculator. Negative 1 to the third power is negative 1. Negative 1 squared is positive 1, so that stays plus 3. And then we have this minus 2 plus c. Now, I would do this piece by piece just because that's how my brain works. I would add 2 to get 0, subtract 3 is at negative 3, and then add 2 from negative 3. I would get a c value of negative 1. But you guys might work through this slightly different. You might say, oh, well, negative 4 plus 3 is negative 1. So if I add, oh, yikes. I must have done this wrong. Typical Mr. Higbee. Okay, add 2 to 2, you get 4. Minus 3 is 1. And add 2 over. You get a c value of 3. Let me double check. I seem to be making mistakes. Negative 2 plus 3 is 1. Minus 2 is negative 1. And if I add 3 to that, I will get a c value of, a y value of 2. Okay, so I'm convinced that that's the right answer. I'll check the answer key in a moment. So what you need to do now is go back to this problem and type in your c value. There we go. And you know me already. I'm going to check the answer key just to make sure I'm not. Yep, it was c equals 3. So maybe it would have been better if I did the problem slightly different. Oops, there we go. So again, feel free to hit pause on the video at any point if you need extra help. With the next problem, it's set up pretty nice for you. Again, you want to do your separation of variables. And while I'm at it, I might as well show you how you can divide each piece, because it's been a while since we've done this. That would be x to the negative 1/2 power. And then I can take 12 divided by 2 is 6. and don't forget that you subtract your exponents. So 3 halves minus 1 half would be 2 halves, so it'd just be x to the first. And while I'm there, I'm also going to multiply the dx over. Again, ignore this initial condition for now. So we're ignoring this until we get to figuring out what c is. So now we can integrate both sides. So you can see we get y equals, add 1 to your exponent, multiply by the reciprocal of your new exponent. Well, 2 times 1 half will cancel. If you want to write down plus, or 1 right there, that's fine. Add 1 to your exponent, multiply by the reciprocal, or 6 divided by 2, give me 3, and then a plus c value. Well, now we can consider that initial condition when x is 0. Well, 0 to the 1 half power is 0, 0 squared is 0, 0 plus c is c. You get a y value of 2. So then what's our final answer? And I would actually just leave it like this, but some people might switch over to square root of x plus 3x squared plus 2 will satisfy the derivative, the differential equation, and the initial condition. So depending on the author of this, you might write a slightly different answer. But again, this might make more sense to you than the way I do the problem. Switching back over, let's get a little bit more complicated, because if you notice in the first two problems, we only had x's on the right side, so it worked out pretty nicely. Well, what if we also have a differential equation that has a y over there? Well, the easiest way for me to explain it is just think of it as cross multiplication. Sometimes I don't like that explanation because sometimes the y is in the numerator, but to move something from the numerator to the other side would be to multiply by the reciprocal. So we can still work with that. But right now, to move 2y to the left side, because you need the y's together, that's the separation of variables. We have 2y dy, and then I'm just going to multiply dx to the right side. So we're looking at x squared plus 2x. So now, again, this will probably get you a point on the AP exam. So then you can do the antiderivative. If anybody's curious why it's worth so many points, is because they want to see the correct antiderivative on both sides. So remember, you add 1 to the exponent and divide by the new exponent. Now here's the thing, is technically there is a plus c on this side, but we don't normally write it. I'm going to leave it there though, and that's why I did a faint color, because I've gotten you in the habit of writing plus c over and over again. But I'm going to talk about that here shortly, so you don't have to write that right now. So antiderivative of the other side, 1/3 x cubed, plus add 1 to your exponent and divide by that new exponent. 2 divided by 2 is 1. This one, I am going to write the plus c. And here's the thing, is in any differential equation, you could have a plus c on this side and a plus c on this side. So let's think of it this way. These c's could be different. This constant could be 12, and this constant could be 50. I'm just making up numbers. So if you were trying to solve for y, you would subtract the c value over, c naught, and you could get any other constant. In my example of 50 minus 12, it's still a constant. It's just 38, it's a different constant. So instead of writing all of these plus c's, we only write one of them, and we disregard the c on one side. And if I show you the answer key, he doesn't even mess with writing a plus c on this other one. So that's normal when you're working through a math problem. So we only need one plus c on this separation of variables. And then we have this other piece as well. So we're going to figure out what the c value is, and we're going to plug in 0 for x's and 2 for y. Well, if we do 2 squared, and I'll show the work, although I hope this is obvious for you that the zeros will cancel, and we're left with a constant that's equal to 4. So what our final answer is would be y squared is equal to 1/3 x cubed plus x squared plus 4. Now, I'm kind of hesitant to do this, but I do need to explain it. If you notice in the directions, I have not even mentioned it, every answer that they expect to see needs to be y equals. So I do need to explain this. I almost stopped, but I have to explain it this way. So because our answer in number 3 did not say y equals, we have to solve for y. Well, that's pretty easy on this problem because we can easily solve for y by square rooting. Now, this last step, so you might want to write that down, but I'm going to over-explain this, hopefully, is, we got a point for separating variables. That's one. We got a point for the correct antiderivative. So 2 points, 3 points. We got the 4th point for finding the correct c value. You usually get the 5th or 6th point by writing the correct equation. Now, here's the thing. When you square root, you do get 2 answers, a plus and a minus. But only one of those answers is correct. And don't automatically assume it's always the positive one. Because if you go back to the initial condition, the y value we got was positive. That's why our answer is the positive version. Because what if the initial condition had a negative here? Well, what would have happened if I squared a -2? I still would have gotten a positive 4 for that c value. So that's the reason why we ignore the negative, and your correct answer is just the square root of 1/3 x cubed plus x squared plus 4, and that's what we want. All right. So again, feel free to pause the video and really understand this. I definitely want to work through the next one. I think I have enough time. I have about 3 minutes. So separate your variables, or you could try it on your own. Hit pause and see if you get the same answer as me. So that'll get you a point. Antiderivative of that. Again, I'm cross multiplying. So the antiderivative, add 1 to your exponent. And then over here, add 1 to your exponent. Plus 2x plus c. And it's actually fine if you just leave your answer like this for right now. And then do your initial condition, just to change colors. -3 when I square is 9. Positive 9 halves, if you notice. 1/2 times, I'm plugging 1 in for x. So 1 squared is 1. Plus 2 times 1 plus c. And that's why I'm saying you don't have to solve for y right away, because what you can do is just figure out what this c value would be. Well, if I subtract 1/2 over 9 halves minus 1/2 is 8 halves, which is 4, minus 2 will give me 2. 2 plus 2 plus 1/2 is 9 halves. So now I can replace that in for this c. So I'm going back to my work. 1/2 y squared is equal to 1/2 x squared plus 2x plus 2. Well, to solve for y now, I need to multiply everything by 2. So this times 2 will just give me x squared plus 4x plus 4. That's why you didn't have to solve earlier. You may have gotten a different c value if you multiplied everything by 2 earlier, but it does eventually become 4. And then when you square root that, why am I writing negative square root of x squared plus 4x plus 4? Well, if you go back to the initial condition, we only got a negative value for y. So if we don't have that negative, we'll get the wrong answer. So just to show you an answer key, pretty much it worked out the same exact way as I did, a little bit more work, and he explains this last step. It was plus or minus, but we only wanted the negative here. And I'll see you in the next video for the rest of these notes.